Yeah,
Okay.
this is recording, I think.
Yep, I'm recording it.
Okay. The skull is an irregular bone, but actually the skull, it's made up of a bunch of other tiny bones or that are joined together by sutures. And I think these bones are flat bones.
Yep, they
Or
are.
like something like the mandible, which is your jaw, that's irregular.
Also about sesamoid bones, so your kneecap actually isn't the only sesamoid bone in your body, but it's like one of the main ones because, like Joe said, the definition of a sesamoid bone, you might want to write it down. It's a bone that's embedded in a tendon. And so what a tendon is a kind of connective tissue that connects muscles to bones. So you find these bones inside like tendons that are in your hands and your knees and your feet. And basically what they do is just they help protect your tendons from stress and breakdown.
What do each of these do? I'm kind of confused, but I know like what they are, but what do they do?
We'll be talking about that later. So
Okay.
So these classifications, they're just by structure.
Okay.
So all the examples I give, they're singular examples. They don't represent the whole of the entire group. A sesamoid bone is a bone that is embedded within a tendon. And yes, this meeting is being recorded. Flat bone is just flat. That's it. The names are like, they're basically descriptions. Yeah. Okay, so is everyone done copying or does someone still need time? Okay, I'll move on. So from what you guys learned before, does anyone know what these bone types are? First one, the humerus.
You like the first one.
Long bone? Yes, correct. Okay, the rib cage. What kind of bone is that?
Irregular.
Irregular.
Yeah.
Irregular.
And the tarsals, these are the bones that are in your foot.
The short one.
They're the
Short?
colored ones. Yes, that's
Short.
correct. Okay, that's nice.
good job.
So types of joints, these classifications are based on the joint mobility. So there's synarthrosis, amphiarthrosis, and diarthrosis. You can remember them by remembering the acronym SAD, which, yeah, okay, so synarthrosis, these joints are immobile or nearly immobile. The examples are the sutures in your skull, like I mentioned earlier. Skull is made up of many different bones, and they're connected by sutures, which are these lines in between each of them. And as you know, you probably can't move your skull bones around, so these are synarthrosis. Amphiarthrosis have limited mobility. An example are the vertebral discs inside your spine. So they can move, but they're not extremely flexible. And then diarthrosis are the most movable joints. They're also known as synovial joints. And don't confuse synovial with synarthrosis just because they have the same first three letters. I did that a lot. And so diarthrosis, they're movable. They're like the bones in your elbow or your knee. Does everyone, you can copy this down.
Does everybody know what a joint is?
Yes.
Yes. Okay.
All right, so for those of you, if any of you don't know what a joint is basically where two bones come together. And so sometimes you can move them like we saw in the amphiarthrosis and the diarthrosis. And sometimes you can't move your joints like in a synarthrosis. So like we were saying.
I have a question.
Yep.
Yeah.
What happens if you break your joint? Is that possible?
Yeah, I guess. Then you would have a lot of pain and trouble. At least the examples, the synarthrosis are the sutures in your skull. I guess you can remember them. They all start with an S. And as you know, you can't move the pieces of your skull around. So yeah, they're immobile. Amphiarthrosis, this is a vertebral disc this blue thing over here, that's an amphiarthrosis joint. You can move it, but it's not extremely mobile. And then diarthrosis they're all movable joints. So like your elbow, which you can move around, your knee bone, your hip bone.
Oh, by the way, you actually can't break a joint. So you guys know what a dislocation is?
Yes.
So you actually can't break a joint because the breaks only happen in a bone or like at the end of a bone. But for dislocations, your bones are going to become out of position within a joint.
How come some people are more flexible? I guess that's training.
I have a question.
Yeah.
So, what does it mean when you said AKA synovial? That's synovial.
Oh yeah, diarthrosis joint, they're also known as synovial joints. Their synovial joints are also movable. They're the same thing.
So far, it is the intro to skeletal. But I still took notes just in case.
Not all of them are ball joints. We'll move on to that later in the next slide.
Is everyone good to move on?
Okay.
Yes.
So these are types of synovial joints, and they're based on structure. Like Alex mentioned, the first one is a ball and socket bone. This one has the most mobility, can move around in all directions. And it's kind of similar to a joystick on an Xbox controller, if you guys use that. And an example is your shoulder bone, your shoulder joint, where your humerus connects to your shoulder. That part, that's a ball and socket joint, so you can notice that you can move your shoulder around pretty flexibly. The next one is a pivot joint, and it's kind of like in this blue picture over here, it's like a circle that's turning within this curve part.
Wait, can you repeat the ball and socket one?
Yeah, ball and socket, it's a ball inside this top thing, and it has the most mobility. You can move it in all directions. An example is your shoulder bone. Shoulder joint, which if you notice, you can move your shoulder around pretty easily.
Okay.
A pivot joint, that's like a circle turning within this curve over here. An example is in your ulna. So your humerus, actually, if you hold your hand out in front of you and then you flip it over, your humerus is turning, it's rotating within your ulna. And so when you have your palm held up, your humerus and your ulna are parallel to each other. And when you have your palm facing down, your radius is crossing over your ulna. And so this movement is actually known as pronation and supination. Yep. So saddle joints, it looks like two saddles overlapping with each other. These have a okay amount of mobility. It's not as much as ball and socket. And an example is the joint at the end of your thumb. If you want to take notes, you can always add more notes. pronation, pronation. And next is condyloid. Sorry. The saddle joint. It's like, as you can see from the picture over here, it looks like two saddles that are over each other. The movement, it kind of moves from side to side. An example is the joint in your thumb. Okay, so next joint is condyloid. It's kind of like the ball and socket joint, but it isn't as mobile. It can move like up and down and from side to side. And I guess an example are joints in your fingers and sometimes in your wrist too. And then plane joints, these are the least mobile out of all the synovial joints. It's kind of like a plane, two flat surfaces rubbing against each other. And some examples are the tarsals in your ankle. So you can see, if you can see the outline in blue, those are plane joints. And then the last one is a hinge, which it's kind of like a door hinge. If you guys ever opened a door before, I don't know if you have. And an example is your elbow, which if you kind of move your arm around, you can realize that it opens like outward and inward, which is like a door.
I don't get what the plate is.
Plane, so I guess, say you had two books and then you like stack them on top of each other and you move them around. If they move in like, the way they move, that's kind of like a plane joint.
Oh, okay.
Okay, so examples of the synovial joints. A ball and socket, it's like your shoulder joint, which your humerus is the ball, and your scapula, I think, is the socket. And you can move your shoulder around pretty flexibly. The pivot joint is like your humerus and your ulna, which are the bones in your forearm. So if you flip your hand over, your humerus is rotating within your ulna.
Can you repeat the saddle joint?
Yeah, saddle joint. That's like, if you can see it in the picture, it's like two saddle-shaped objects, kind of like a U, and then they're rotating within each other. They kind of move side to side, maybe in this kind of circular motion. An example is the joint in your thumb, at the end of your thumb.
Okay.
I'll repeat pivot. Pivot is like the joint and in your humerus and your ulna, which are the two bones in your forearm. And when you flip over your hand, your humerus is rotating within your ulna. So that's what the movement is. A condyloid joint, it's like a ball and socket joint, except it's not as mobile. It moves from side to side and forward and backwards. And so examples are maybe some joints in your within your carpals, which are your wrist, and your finger joints too. Plane joints, they're like two flat surfaces moving around each other. Like if you stack two books and you move the top book around. And examples are the tarsal bones, which are in your foot, your ankle, yeah. And then a hinge joint is like your door. You can open it outwards, inwards. It's like your elbow joint. What would happen if you had joints in the wrong place? Well, that would be very unfortunate because then you'd be moving very awkwardly. is head to neck condyloids. So your neck is made up of vertebrae, which are part of your spine, and these vertebrae are known as cervical vertebrae. So you have two vertebrae which are kind of pretty crucial in moving your head, and that's your atlas and your axis. So your atlas is the very first cervical vertebrae, which connects your skull to the rest of your neck. And I kind of forgot how that one moves. I think it's kind of like ball and socket, but I'm not sure. You might want to check me up on that. And then your axis is the second vertebrae, which is right below the axis. And I think that's the one that gives your neck its mobility. Examples of plain synovial joints. That would be like some joints in your ankle, which are your tarsal bones. Like I think it's kind of small. You might be able to see it better. Oh, I can use a pointer. So over here, you can see the outline in blue. These are all plain joints.
All right. Do you want to move on? I think
Yeah.
a lot of the questions I think can be answered if you watch the recording, which we'll post later. But yeah.
Okay, so next are types of cartilage. There's hyaline, elastic, and fibrocartilage. So hyaline cartilage is made up of fine collagen fibers. In case you guys didn't know, collagen is like one of the structural fibers of your body. There's it's one of the strong ones. So there's like I think there's collagen, elastic, and reticular fibers, and collagen is the strongest one out of the three of those. But notice how it's fine collagen fibers. So hyaline isn't the strongest cartilage out of all three of these. Is a part though, it's found in all your articular joints or your synovial joints. So you can see the picture over here, that's a synovial joint. And the blue stuff that's covering the end of the bones, that's cartilage. And this is all hyaline cartilage. And this is, by the way, this synovial joint, it's like a fluid-filled cavity. And so when you, the fluid, which is known as synovial fluid, kind of cushions your bones when they move, which makes it more flexible. And an interesting fact is, before your gym class, you know how you have to warm up? That's actually while you're moving your joints, it warms up your synovial fluid, which makes it more it makes it flow easily. So that helps you move better, which is why you have to warm up before you exercise. And then other places where you can find hyaline cartilage are costal cartilages, which connect the ribs to the sternum. In case you didn't remember, sternum is the flat bone over your chest. And then they're also in the larynx, which is your voice box, and the upper respiratory passageway, which is where your air goes through when you breathe in. And hyaline cartilage is also in your nose. So you can copy that down. Do you know what time it is?
It's 10:35.
Yeah, I have a list already. Okay. I think we have time.
Yeah, I think we'll have time
No,
in the next.
hyaline cartilage is not in the ear. That is actually elastic cartilage, which you'll learn about next. So I'll move on to the next one. You can go back later. I'll post the presentation on Classroom. So the next one is elastic. It has more elastic fibers, which are one of the three fibers I mentioned earlier. Elastic fibers are yellow, so this cartilage is sometimes known as yellow cartilage. And as you know, as it's in the name, elastic cartilage is more elastic. It's found in the ear and also in your epiglottis, which is this little flap thing that prevents food from falling into your lungs or your airway passageways. And then the last cartilage is fibrocartilage. This is made from thick collagen fibers, which I mentioned before. Hyaline cartilage is also made from collagen fibers, but these are fine collagen fibers. So fiber cartilage, it's the strong one. It has great tensile strength, and it's found in the menisci of your knee, which is over here. That's your knee. So as you can see, this little thing that's going around the bone on the bottom, that is the meniscus, and that is made of fiber cartilage. And don't mistake it for the stuff that's going vertically around your knee. All of these are ligaments, not cartilage. And then it's also found in the intervertebral discs, which is in your spine, over here. Can we go back to elastic cartilage? It's your ear and your epiglottis. And a reminder, epiglottis is that flap that prevents food from falling into your airways, which is why you guys shouldn't talk while you're eating. And then here's fiber cartilage. Okay, so I'll move on. Bone parts. There's compact bone and spongy bone. This is also known as cortical and cancellous bone because, you know, scientists like to make our life harder by naming things multiple stuff. Compact bone is that hard outer layer on the outside of your bone. It's what most people see and think about when they think of bones. And it's 80% of your bone mass, which is a lot. Then spongy bone is the interior. So contrary to some beliefs, your bone is not completely solid. It does have some like air gaps or spaces inside. That's your spongy bone. Because if your bone was completely compact, you would have a very difficult time moving around. So spongy bone is on the interior. It's made of trabeculate, which looks like this. And you can see that the surface area to volume ratio is very high. And then it houses red bone marrow, which we'll explain on Thursday. So do come back next time. And red bone marrow, just for a brief explanation, that's the stuff that makes your blood cells. And spongy bone only takes up 20% mass, even though it fills out the interior of the bone. So you can copy this down. So does everyone understand today's presentation? If you have any questions, you can type in the chat now. Cool, so here's some review questions that you guys can answer. Which of the following are diarthrosis joints? Searchers, elbow, vertebral disc, or finger joints? By the way, it's R, so there's multiple choices.
I have a question.
Yeah?
Are you gonna post the recording right after class?
Yeah, we are.
Okay.
Okay, correct. It's elbow and finger joints. You can move these around a lot. A reminder, diarthrosis joints are synovial joints. They're the most movable joints. Okay, a ball and socket joint is like which of the following?
A door. A door?
No, sorry. A door is like a hinge. Because, you know, a door hinge. And it opens, it moves like your elbow.
Joystick.
Wait,
A joystick?
Yes, it's like a joystick. If you guys play Xbox, then you might have used an Xbox controller before. Those are like a ball and socket joint when you move those around.
Someone wants to know what sutures are, so should we go back to the slide?
Sutures. They're they're the lines that connect your cranial plates, which are in your skull. And a reminder, sutures are synarthrosis joints. You can't really move them. I don't know anyone who can move their skull pieces around, so. Okay.
Wait, can you go back to the bones? I didn't get the compact bone notes.
Oh. Here?
Yeah. Okay, thank you.
Okay, no problem.
Wait,
Yeah.
can you go back to the compact for 1 second?
Yeah.
Okay. Let me just copy these down.
Okay, I'll post the presentation on Classroom later so you guys can look over all these slides again. I'll move on to the questions. Ossicles are part of the axial skeleton. Is that true or false?
False.
Okay, so it's true.
Really?
Yes, because
Oh yeah,
ossicles,
like the ear, the ear.
yeah, they're the little bones in your ear. It's not part of the skull, but it's part of the axial skeleton. And then number 4, spongy bone takes up more mass than cortical bone. Is that true or false?
False.
False.
Correct. Spongy bone only takes up 20% of your bone mass, while cortical bone takes up 80%.
I like to say cortical. Why can't you just say like compact?
Oh, you can say both. You kind of have to know both terms though, which is it's annoying, but you know, that's science.
Okay.
Sutures, reminder, these are your skull. It has a lot of different pieces. It's not just one large piece. And all these pieces are connected at sutures. Okay,
ossicles,
so,
by the way.
yeah.
Oh, someone was asking what ossicles were. They're just like the tiny
ossicles?
bones in your ear.
Yes, that's correct. They're little tiny bones in your ear. So we'll be playing Scriblio. And there's terms over here. Wait.
All right, so Joes, if you